This video summarizes the Math 1 lesson titled New Slopey Formations. This is a develop understanding task. The purpose of this lesson is for students to discover and explain the relationships between slopes of parallel and perpendicular lines. So Podunk High School drill team are still thinking about different formations, and they've come up with some new creative designs. Haley and Isabella want to hold a ribbon between just the two of them, but they want their ribbon to be parallel to Courtney and Farah. Then they want Jacqueline and Caitlin to stand in similar spots to the left side of the formation and hold a ribbon that will be parallel to Abby and Debbie. So first let's draw where Jacqueline and Caitlin will stand. So to draw where Jacqueline and Caitlin will stand, they want to be over here in this area, but they want to be parallel to AD and the same distance away from AD as HI is to CF. So if H is 3 units away from C, then let's put Jacqueline 3 units away from point A, from Abby. And then Caitlin will be 3 units away from Debbie. Number 1 asks, how can you justify that segment CF is parallel to segment HI, and that segment AD will be parallel to where you put points K and J? But answering this question, you might reason through it visually, maybe using patty paper or a similar tool to where you can draw a segment and then you can just slide that segment around. I have the benefit of doing this with technology, so I know that the line is not going to tilt. So I know that HI has the same tilt as CF, so these segments are parallel. AD has the same tilt as JK. Now you might think of this as a different way. Instead of actually drawing a line to translate around the page, you might understand that if A and J are 3 units apart and D and K are 3 units apart, since they're maintaining the same distance, then this segment JK will be parallel to this segment AD, and HI will be parallel to CF. So Gabriella notices that her formation is using some geometry facts that she's learned about math in class. She says to her new and growing group, hey, I wonder if when we write the equations of the lines CF and HI, if there's anything special about them. So let's write the equations of the lines that would pass through point CF, making line CF, and then also line HI. And what do we notice about the equation of those lines? So CF, if I want to write an equation that passes through those points, I don't see a y-intercept there easily to get, so I'm going to use point slope form. So I have y equals m and then parentheses x minus x sub 1 plus y sub 1. I'm using our point slope form. So y equals the slope of, let's start with CF, is 1, 2, 3, 4 over 2, or 2 over 1. So the slope is 2. I'll have x minus, and then I need a point here. So let's just use point C. That's 1, 2, 3, 4, 5 over 5 and up 2. So 5 plus 2. So that's for CF. Next, I'll do HI. Now HI, y equals, I'll get my slope, go up 1, 2, 3, 4 over 2. Then I have the slope 4 over 2, which would simplify to 2. And then I'll use the coordinate of h, which is 1, 2, 3, 4, 5, 6, 7, 8, 2. So x minus 8 plus 2. And what do you notice about the equations of the lines? Well, what I notice is that they have the same slope. Now the points that I chose happen to be at the same y coordinate, but I could have, when I wrote the equation, I could have used point I instead of point H. So that's something that wouldn't necessarily happen. It's just the point that I chose. But the slopes, that would not matter which point that I chose on the line. The slopes would be the same. Number 3 asks to write equations for line AD and line KJ. What do you notice about the equations of all 4 of these lines? All right, AD. So AD, I'll start with y equals, and then I need the slope. So I can go up 2 over 1, up 2 over 1. So the slope is 2. And then x minus, I need a point, 1, 2, 3, 1, 2. So this is negative 3, 2. And then I'm going to do, so that's AD, and then KJ. The slope is still 2, and then I'm going to use the other coordinate. I'm going to use point K here. Negative 8, negative 2. So I'll have plus 8, minus 2. So again, we have slopes that are 2. So what do you notice about the equations of all 4 lines? All 4 of these lines have a slope of 2. What's important to take away from this task is when you have parallel lines, the slopes will be the same. The dance team designs another formation, and Gabriella is impressed with the design and keeps wondering why these types of patterns are so visually appealing. She decides to focus on one small piece of the design to work her math calculations again. To compare the line segments, GC and GE, Gabriella decides to cut out a sticky note that will represent the slope of the line segment that goes from herself to Courtney. She starts with her own position at the origin, and she counts up and to the right. From Gabriella to Courtney, we go up 2 and then over 6. She remembers learning about rotations in middle school and wonders what would happen if she holds her corner down at point G, then rotates her triangle 90 degrees clockwise. Cut out your own triangle and make observations about the rotation. She's going to hold point G down and rotate 90 degrees. So after I have rotated the triangle, I can see that this segment lies directly on segment GE. It coincides. Now question 1 asks, what do you notice about your slope triangles for these 2 lines? So the slope of GC was up 2 and over 6, which would simplify to 1/3. The slope of GE is down 6 and over 2, which would simplify to negative 3. There's an interesting relationship here. We rotated the triangle 90 degrees, and the segment that was on GC landed perfectly on GE. So we know that we have 2 line segments that cross at 90-degree angles. Number 2 asks us what type of intersecting lines cross at 90-degree angles, and the answer to that is perpendicular lines. The task continues to ask similar questions for you to find the slopes and compare them, and the same relationship happens. Here we have 1 over 3, and then this one is negative 3 over 1. So when lines are perpendicular, you have what's called opposite reciprocal slopes. Opposite because one is positive and the other is negative. Reciprocal because the fraction has been flipped. So 1 over 3, and this is negative 3 over 1. This means that if you have lines that have opposite reciprocal slopes, those lines cross at a 90-degree angle, and they are called perpendicular. To summarize, parallel lines have the same slope. Slope measures the rate of change of a line or line segment. Parallel lines are changing at the same rate. They all have the same rise over run. So since they are changing at the same rate and have the same rise over run, the slopes are going to be the same. Perpendicular lines have opposite reciprocal slopes. So for example, if the slope was negative 2 over 3, the opposite reciprocal slope would be positive 3 over 2. The slope of 5, or 5 over 1, would be negative 1 over 5. So opposite is when you change the sign, and reciprocal is when you flip the fraction. That's all for this video. Thank you for watching.